Hey, college algebra students. Today we're looking at the quadratic formula on college algebra with Mr. Forbes. Notes out, and away we go. This is the same quadratic formula you looked at in Algebra 2. And let's derive that formula. So we had to do complete the square first because we're going to use that in this process. So ax squared plus bx plus c equal to 0. The way we're going to get our formula is we're going to multiply everything by 4a. And we need to multiply everything by 4a so that we're able to complete the square. That gets us 4a squared x squared plus 4abx plus 4ac is equal to 0. Now we're going to complete the square. To complete the square, we need to move the constant term to the other side. And as we get through this, you'll start recognizing the pieces. See, there's the minus 4ac right there. Now we need to complete the square. To do that, we're saying, what do we multiply to get 4a squared x squared? Well, that's 2ax plus, well, there's part of it right there. Where'd that come from? Well, that had to come from, there's two abx terms. So 2abx plus 2abx. And so we want, what's the missing piece for that? Well, that's just the x squared. Now we need to complete the square by adding back a x squared. And I did that wrong. That's not an x. We're missing the b. That's a b. So we're adding back the b squared. If we add it to one side, we have to add it to the other. And I'm going to rearrange this to make this b squared minus 4ac. Now we can solve by square rooting. Therefore, we get 2ax plus b is equal to square root of b squared minus 4ac. Next, we need to solve for b. So there's 2a equal to negative b plus or minus, and I forgot the plus and minus, square root b squared minus 4ac all over. Then finally divide by 2a, and we get our famous formula, the quadratic formula, negative b plus or minus square root b squared minus 4ac all over 2a. So this is going to be another method then we can use to solve a quadratic formula. This works for any quadratic, whether we can factor it or solve it with complete the square. Quadratic formula always works. So here we go. Here's the first thing we need to do. We need to identify what is the a, b, and c first. So here a is 1, b is 2, c is negative 15, and we're just going to plug this into our formula. So x is equal to negative 2 plus or minus square root 2 squared minus 4 times 1 times negative 15 all over 2 times 1. We need to simplify inside. We can use our calculator to do that if the math is too big for you. So this is the square root of, turns out to be 64 all over 2. Square root of 64 is 8, so this is negative 2 plus or minus 8 over 2. No, we're going to have a positive, well, I say a positive and a negative answer. We're going to have two answers. They're not always positive and negative. Negative 2 minus 8 is negative 10, divided by 2 is negative 5. And negative 2 plus 8 is 6, divided by 2 is 3. As with any equation, we can plug that back in and check to see if we get the same answer. Example 2, we're going to do the same thing. First, now we have to get into standard form. We want to usually keep the a term positive if we can. So this is 4x squared. We'll subtract the 12x back to the front, and then add the 9 back to the front. Therefore, a is 4, b is negative 12, and c is 9. We're going to plug into our quadratic formula. Negative 12 makes this a plus 12, plus or minus the square root of negative 12 squared minus 4 times 4 times 9, all over 2 times 4. We'll work that out, and we get, this actually goes to 0 over 8. Well, square root of 0 is 0, so we're just left with 12 over 8, which simplifies to 3/2. What if we have a quadratic with fractions? Well, we don't like fractions, so we're going to clear this with fractions, although you could plug in the fractions and still get the same answer. We're going to multiply by the least common multiple of 6. That gets us 2x squared plus 6x plus 3 is equal to 0. We're going to plug in our pieces. That gets us -6 plus or minus the square root. 6 squared minus 4 times 2 times 3, all over 2 times 2. That gets us -6 plus or minus square root of 12 all over 4. This is why we had to do that stuff in chapter 7 first. Square root of 12 is a factor of 4 times 3, which is -6 plus or minus 2 root 3 over 4. As long as there's a common factor in all three, we can simplify, right? We would normally factor out a 2, but as long as all of these have a factor of 2, we can simplify. We can call this then -3 plus or minus root 3 over 2. Example 4, same thing. A is 1, B is 1, C is -5, +5. And we'll plug in. So x is -1 plus or minus the square root 1 squared minus 4 times 1 times 5 all over 2 times 1. That gets us a -1 plus or minus the square root of -19 over 2. Well, now we get a negative in there. And the reason we had to do chapter 7, what's the square root of a negative? Well, that's I. So our answer is -1 plus or minus I times the square root of 19 all over 2. Again, usually we'll put the I in front of the square root so we're not confused about if it's inside or outside of the square root. All right, so let's look at a summary. We have 4 methods then to solve a quadratic. We can use the square root method. If we have something, a value squared, we can square root both sides. It's best to use that when there is no b. If there's no b squared, so like x squared equals 8, right? We can square root both sides. We can also factor, but that only works when factoring works. Quadratic formula will always work, whatever we're doing, and completing the square will always work when factoring doesn't work. Next thing that we can look at is the number of solutions for a quadratic equation. To tell the number of solutions for a quadratic equation, we're going to use the discriminant. The discriminant is a portion of the quadratic formula. That's the b squared minus 4ac part. It's the term that determines the number of solutions. And here's what's going to happen. If the discriminant, b squared minus 4ac, is positive, right? If it's a positive number, if we get 5, 10, 16, 25, then we have to get 2 real solutions. Right, so if the discriminant is positive, there has to be 2 real solutions. One of the reasons for that is on the graph of a quadratic, then it's going to cross the x-axis twice. If the discriminant is equal to 0, then there is 1 real solution. What happens there in the graph, if there's 1 solution, is if the vertex hit just grazes the x-axis and goes back up. That's when we have 1 solution. And then what happens if the discriminant is negative? Well, then we're going to square root a negative. We can't square root a negative. So there are 2 imaginary. Well, we can square root a negative, but it's not a real solution. It turns into an imaginary solution. So there are 2 imaginary solutions. What happens in that case? Well, in that case, the parabola didn't cross the x-axis. And that's where imaginary solutions occur. So next part is use the discriminant to find the number of solutions. Now we're not going to actually find what the solutions are. We're just finding how many solutions there are. So make sure you read the questions carefully in the homework so you're not doing too much work. So we're going to plug in b squared minus 4ac. b is -3 minus 4 times 1 times -5. When we plug that in our calculator, we get 29. 29 is a positive. Then there are 2 real solutions. Letter B, again, first we want to get this into standard form. So we'll go x squared minus 3x plus 9 is equal to 0. That gets us b squared is -3 squared minus 4 times 1 times 9. That gets us -27. Here our discriminant is negative. If it's negative less than 0, then there are no real solutions, or a better answer would be 2 imaginary solutions. And letter C, plug into our discriminant, -12 squared minus 4 times 9. And when we plug that in, that's 0. If our discriminant is 0, there's 1 real solution. Application question. The area of a rectangular tabletop is 6 square feet. If the width is 2 feet shorter than the length, what are the dimensions? So again, let's draw a picture. Here's our tabletop. It has a length and a width. We know its area is 6 feet. We also know area is the formula length times width. To solve this, we need to get either this equation in the form of length or in the form of width. And what do we know about them? We know the width is 2 feet shorter than the length. So if the length is L, then we know the width is whatever the length is minus 2. And so we can plug in either way. We can also set the length is equal to the width plus 2, however you want to solve. But here I've set it up so that the width is equal to L minus 2. If you want to use X, you can use X. So let's plug in our pieces. Our area is 6. The length is L. The width then is the length minus 2. Again, you can use whatever variable you want. You can use X if you're more comfortable with X. And then we want to solve. To solve, we need to get this in standard form. So we need to use the distributive property, L squared minus 2L. And then 0 is equal to L squared minus 2L minus 6. We can solve this with factoring. We can solve this with completing the square, or we can solve this with the quadratic formula. X is equal to -b, which is going to be a plus 2, plus or minus the square root of b squared, minus 4 times 1 times -6, all over 2 times 1. Here we're going to need a decimal answer. This is an application question. So here we're going to actually plug this into our calculator and get the answers. And the answers we're going to get are 1.65 and 3.65, and that's feet. It's a pretty small table. But that works because one side is 1.65. The other side is 2 feet longer, 3.65. Again, units on it because it is a word problem. And here's our homework. Lesson 8.2, page 540. We're doing 8 through 42 evens, 68 through 72 evens, and 78 through 84 evens. Have a good day, Maroons.